Good afternoon, guys. I hope you are keeping safe. So, I just want to give you a summary on work, energy, and power. So, the most important for you to know is that work, for you to understand it very well, you must know all there is to know about force. Force, you remember so well, is the push or pull on an object. For an object to move, then there should be a force acting on it. So when the object moves, the product of the force and the displacement is actually what you get as work. And energy is the ability to do work. So those are the important concepts that you have to know. So now, if you have an object and it's moving on a horizontal plane and you are pushing it with a force, if the force is horizontal and it moves a distance, the work is simply force times distance. If that force is applied at an angle, the work is the component of the force in the x-axis. That's if it's moving horizontal, as you've read. The component of the force in the x-axis times the displacement. That's why we get Fs cos theta. And if a force is at 90 degrees, like the normal is always at 90 degrees. The normal is always at 90 degrees. So meaning that normal always does zero work. Let's understand it from that perspective, guys. The normal always does zero work. Also, the weight does zero work sometimes in the instance that the weight is acting at 90 degrees to the direction of the body. On the horizontal surface, weight also does zero work. So you must know that. So on a frictionless surface, the force you have applied to move an object is also the net force. Because if you remember, the net force is a total force. So if you've only applied one force there, then that is also the net force. The other aspect that you must know is that the net force is always equal to the change in the kinetic energy of the body. It's always equal to the change in the kinetic energy of the body. You remember, so for something to do work, energy is converted. So there's a gain in kinetic energy if the work is positive. So always remember that aspect, guys. That's why you find we say work net is always equal to the change in the kinetic energy. We say work net is equal to m over 2 open brackets v squared minus v naught squared close bracket. So you must know that. Then the other aspect, which is also key, is that the work done by the weight is not always zero. It's only zero if you're on a horizontal surface and the weight is at 90 degrees to the direction. It changes if you push an object up an inclined plane. Then it ceases to be that. Then it's not always that the normal force is equal to the weight. The normal force is only equal to the weight if you are pulling on a horizontal surface. If you are pulling on a horizontal surface with a horizontal force, then the normal force is equal to the weight. But if you pull at an angle, the normal force ceases to be equal to the weight. You have to get, for you to get the normal, you subtract, you say weight, normal equals weight minus mg sine theta. Why? Because there's an angle there. Remember, we're talking about the horizontal surface. On a vertical plane, it's the same case. The weight or the force that you have applied must also be in the same direction. So now, when you are getting the net force on horizontal plane, you just get the force in the x minus the opposing force. So if there's an opposing force, which is, there's a rough surface now that has friction. So on a horizontal surface, you just subtract friction. But then when you're going up a plane, you must remember the weight goes into play. It also starts acting. The weight, if you know so well, guys, you agree with me, that it's easier to go up a plane, it's easier to go down a plane than up a plane, because to go up a plane is difficult. You find you get tired. Those of you who've lived in areas where there are hills and mountains, you attest it's very difficult to go up but easier to go down. Why? Because gravity goes down. So when you're going up, gravity is opposing you, just like friction. So the work done by gravity, which is the gain in potential energy, the work done by gravity is mgh. But then sometimes you find using our SOHCAHTOA, we also say mg s sine theta, meaning the s sine theta is equal to the h. Those of you, if you revise the SOHCAHTOA very well, you understand. So mg h sine theta, that is the force of gravity, meaning the work done by gravity is mg s sine theta. So remember that force, you subtract it when you're going up, when you're finding the net. You subtract it together with friction. So meaning when you're getting the net force, you say work net is equal to work by applied force minus friction minus work by gravity. Work by gravity is gain in potential energy. You subtract it. But then when you're sliding down, the gravity is on your side. You have to add it. Sometimes sliding down doesn't even require an applied force. No one should push you to slide down. You slide down on your own. Those of you who've been to play parks, on a slide, you understand. So that force goes in that direction. So let's understand that perspective. So meaning that is how we get on an inclined plane. The last point, which is very important, is that if the force that you have applied is equal to the friction, then the body will move at a constant speed. So for constant speed, meaning for constant speed up a plane, the force you must apply going up must be equal to the force of gravity and the force due to friction. That is key. That is all, guys. So don't ever stress. Don't ever stress. So meaning if someone asks you to find the power there, you just add those two forces, because that's applied force times the velocity, then you'll get. So don't stress. These are simple concepts. So always when you apply the force equal to the opposing, then there's constant speed. Then remember, power is work over time, or power is force times velocity. So meaning to get your power, you must calculate the force that you have times the velocity if you have the velocity there. Considering that the velocity is constant. Then there's now so many things. When you just grasp these aspects, then you have understood all there is to work, energy and power. Enjoy your stay. I miss you guys a lot. I miss you. We didn't plan for this. I have never done this, but we are learning together so that you guys get the knowledge you deserve. Pull up and act well. Thank you very much, guys. So I think those are if there are any gray areas that I've left, we'll look at them later. The last gray areas that I've remembered is that when you're getting energy at point 1 is equal to energy at point 2 if there's no friction. If there's friction, then energy at point 1 is equal to energy at point 2 plus the work to overcome friction. Enjoy your day, guys. I'll always be missing you. And let's pray that this scourge ends. Thank you.